Hey guys, welcome to the next video on NumPy tutorial for beginners. In this video, we will see some of the basic operations which are related to NumPy arrays. So let's get started. I have already imported NumPy into this Python console, and now I'm going to create few NumPy arrays. So first of all, let's create the first NumPy array, and this array will be the one-dimensional array, and this will contain 3 elements 1 2 3. Pretty simple. We are going to create the second NumPy array, and this time this array is going to take 2 dimensions. So first of all, inside the square bracket, I'm going to add one more square bracket, and here I'm going to just write 1 comma 2. Now, as we have talked in the last video, that NumPy array is somewhat similar to Python list in terms of iterating over them. So this means they have some index. So we can just fetch an element of an array using its index. So let's say I want to get the first element, which is 1, from the array A. Then I can just write A square bracket 0, which will give me the element at 0th index. So working with this one-dimensional array is simple. We can just give the index here and it will give you the element related to it. But when it comes to two-dimensional array, what we can do? So similar to the list, when we just want to fetch the 0th element of the list, it's going to give us this result, which is the first element of the array, which is this list 1 comma 2. Now let's say you want to get this element, which is 1, which is at first row and first column. Then what you can do here is you can add one more index, which means we want to get the element at the first row and first column, and it's going to give us 1. Similarly, you can give any other index and it's going to give you the element related to it. And you need to notice one thing here is because the index starts from 0. So when we give 1 comma 1 here, it's going to give us 4. Now there is a function called matrix also in the NumPy, which we can use instead of array, which is going to give us the multi-dimensional array. So I'm going to just show you how you can create the matrix using NumPy. So you can just write np.matrix, and here you can give the same type of elements. Let's just copy this array and then paste it here, and when I print the content of m, it's going to give us the same result as we get in the case of array. Now in the NumPy documentation, it is recommended that we use arrays, so we will not bother much about the matrix, but I just wanted to show you that there is a method called matrix which you can use to create matrix or multi-dimensional array. Now there is one more notation which you can use to get the similar kind of result for getting some value of some position, and this time what I'm going to do is I'm going to use b, and then let's say I want to get the element at 0th index, right? So I'm going to just write 0 comma 0, and notice here I have used 2 square brackets, but there is a shorter notation which is 0 comma 0, which appears more like matrix operation. So when I do this, it's going to give me 1, which is the same result as we have seen here in the case of indexes. Similarly, when I do b 1 comma 1, it's going to give us the result 4. Now, as I said, NumPy array behaves similar to the NumPy matrix. That means we can perform the matrix operations on the NumPy array also. So what I'm going to do is I'm going to just say b dot t, which is going to give us the transpose of this matrix. So let's print out the content of the NumPy array B also. So the original content of the NumPy array B was this one, and after transposing, the result is this one. Now there is a property called shape which we can use to get the dimension of the NumPy array. So let's say I'm going to just write b dot shape here and then press enter, and it's going to give us this result, which is 3, 2. So this array is having 3 rows and 2 columns. 1 row, 2 row and 3 row, and number of column is 1 and 2. Now let's say we want to transfer the transpose of b into a new variable. So I'm going to just write b dot t and assign it to c. And now we want to see the shape of this C NumPy array. It's going to give us this result, which is 2, 3, which means that now C array contains 2 rows and 3 columns. Now when I have created these two arrays A and B, I told that A is the 1-dimensional array and B is 2-dimensional array, and there is a property also to verify this, and it's going to give us the dimension number of a particular ND array, and this property is called ndim. So I'm going to just use b dot ndim and then press enter, and it says that dimension number of b is 2, which means it's a 2-dimensional array. And when I do the same operation with the array 1, then it's going to give us 1, which means that this A array have the dimension number of 1, which is 1-dimensional array. Now there is a property called size, so I'm going to just write b dot size, and this property size is going to give us the number of all the elements present in the array. So this array B contains 6 elements, 1, 2, 3, 4, 5, 6. That's why it gives us result 6. Similar operation when we do on the array A, then it's going to give us 3 because it only contains 3 elements total. Now there is one more property which is called dtype. It's going to give us the data type of an array. So I'm going to just write a dot d type, and it's going to give us dtype is equal to int 32. Also in the case of B, it's going to give us int 32. So let's print out dtype of the array B, and it's going to also give us int 32. That means each and every element of this array is of data type integer. Now in order to create the array with the floating values, what we can do here is, so I'm going to just declare one more variable d, and then I'm going to create one more array, and this time I want to create the array with the floating values. So what you can do here is, as you may expect, that you can provide the floating values here 1.2, and then I'm going to press enter, and when I just want to know the data type of this d, it's going to give us this result, which is float 64. Or there is one more way of creating an array with floating points, which is np dot array, and then what you can do is, let's say we just provide 1 and 2 here, and you want to convert the array of integer into the array of floats, then what you can do here is you can provide comma and provide one more argument, which is the type, and then provide the value of it. So np dot float 64, and then press enter, and once you see the content of this array E, it's going to give us this kind of notation 1.2 point, and this means the array contains float 64 values. So this we can confirm from the data type of E, and you can see it contains elements of type float 64. Now there is one more property of the NumPy array which we can use here is item size. So this is a property and it's going to give us the size of each and every element of this array. So because this array B contains integers, and we all know that integer takes 4 bytes, and that's what it's showing here. In case an array contains floating value, let's say this E, which contains floating values, let's see the item size of this array E. It's going to give us the result 8, which means that the size of each element in the array in byte is 8. Now there are some basic function available for the NumPy array. So let me print out the content of B once again. So this is our B NumPy array, and let's say we want to find out the minimum of all the elements present inside this array. So we can use this method a.min, which is going to give us the minimum value, and to get the maximum value you can just write a.max function, and it's going to give us the maximum of the array A. Now similarly we can find the minimum of the array B also. So min function, which is going to give us the minimum value present inside the array B, and to get the maximum value you can just write b.max, and it's going to give us the maximum value present inside this array, which is 6, which is this one. If you want to get the sum of elements, you can use the sum function. So a.sum, which is going to give us the sum of the array A, and b.sum, which is going to give us the sum of the array B. Now let's say you want to find out the sum of a particular axis. So when you see vertically, this is the axis 0, and when you see the array horizontally, this is the axis 1. So let's say we want to find out the sum of the matrix B, and we want to find out the sum of axis 0. So I'm going to just write axis is equal to 0 here, and then press enter, and you can see it gives us 9 and 12. So from where does this 9 and 12 come from? 1 plus 3 is equal to 4, and 4 plus 5 is equal to 9. So this is the sum of these 3 elements, and similarly 12 is the sum of these 3 elements. And because we have said that we want the sum of axis is equal to 0, which is the vertical sum of the array elements. Now in case when I write here axis is equal to 1, it's going to give us this result, which is the sum in horizontal way, which is called the axis 1. So 1 plus 2 is equal to 3, 3 plus 4 is equal to 7, and 5 plus 6 is equal to 11. So this is called the axis 1, and when you see vertically, it's called the axis 0. So these are some of the basic properties and methods related to NumPy arrays. I hope you have enjoyed this video, and I will see you in the next video.